before? You've done the program before? You've
No,
read
I'm just a rock genius. My uncle's a rock geek.
well, and you know, I'm happy. You're a very humble rock geek and genius, but you know what? Keep on with it because it's a wonderful, wonderful field of interest. Personally and professionally, it is actually a limestone, and it is called limestone conglomerate. So conglomerate is when rocks are broken and back together. Breccia is also a type of conglomerate that is volcanic when it's shattered by gas in pieces, which is not the case here for this limestone conglomerate. Now, the limestone conglomerate we have here was broken, and you see the pieces here, and there's a bunch of pieces, cabbage size, fist size. So that's the average. And do you see mostly round lines or mostly straight lines or a mix of both?
Both.
It's kind of a mix of both. You do see round places and you see also straight ones. I'm not talking about a fracture. The bigger fracture that created, carved these block and block like that happened from the cooling of the rock, a bit like a cake that you leave cool will crack. Same thing, it cracks usually in parallel fractures, but the smaller pieces, there is a bunch of small straight lines as well as curved lines. Now that tells us something. That tells us that the limestone, which is a soft rock, which is formed as a leathery material underwater, got broken in blocks, but not for very, very long before it got back all together. Because if it would have stayed for a long time broken in pieces, it would be very rounded everywhere, like pebble on a beach. It was pretty fast. And now it's time for me to reveal to you where, how this was formed, and it has something to do with the location where these rocks were formed. So since the beginning, I told you the rocks of Green Point were formed in the bottom of an old ocean. This is true, but it was in the bottom of the ocean, very close to the continental slope, which is also close to the continental shelf. So the land masses on which we live extend underwater as continental shelves, which are pretty, shallow water, a few hundred meters of water. And it varies, between, it could be 15 kilometers, it could be 50 kilometers, it could be 500 kilometers. If you look at Newfoundland, this is the Gulf of St. Lawrence. This is not the ocean, but St. John's is facing the Atlantic Ocean. And you have the Grand Banks of Newfoundland, very fertile, very plentiful waters, full of fish, because it's very shallow water. And it's almost the same size than the island, just southeast of the island. This is part of the continental shelf. If you look at the Andes Mountains, so you look at Ecuador, Peru, Chile, all this area, very young and straight mountain that extend they are very steep in the water, so the continental shelf around this area is maybe 10-15 kilometers, and then you're in deep water. While here in Newfoundland, this is a much longer continental shelf. So all of this to say that you have the continental shelf, then you have your continental slope, and this is where the rocks of Green Point were formed. And I have a very strong visual here, which was drawn by my colleague Chris, who's a geologist and an artist. And I found this, believe it or not, in the garbage. She was not happy of her drafts, but I saved it. I could have put color on it, but anyway, I classified it before. So what you see here with my finger is old North America. This is Laurentia. We're close to the equator. There's no life on the land, but there's plenty of life in the shallow waters close to the land. And you can see here lagoons, reefs, and in the bottom you see the cross section there. So this is shallow water, and then you see the slope right there. And that's where the rocks of Green Point were formed. And what happened with the layer behind ourselves, that conglomerate, limestone conglomerate, is a very fast event that lasted about this amount of time. I forgot my Jews art. That was it. It happened in the slope. Now, next time you come to the island, we have a beautiful ski resort in the winter. When you come, March is the best month for snow. Marble Mountain by Corner Brook, downhill resort, highest, best slopes east of Quebec, that Newfoundlanders say. And if you ski down in Marble on any other mountain, sometimes you got to be careful. Something can happen with the snow, which would be avalanche. And that's actually what happened to create this layer, an underwater avalanche in the continental slope where these rocks were formed. And there's a couple theories of why we would have underwater avalanche, mostly landslides, maybe earthquake, because it truly is tectonics. You know, it's continents moving towards each other and undulating these soft rocks. Tectonics, but the most plausible explanation is reefs that are building up and over-steepening, so kind of building up too much and eventually crashing down. And basically this layer is pretty thick, you know, 4 or 5 feet wide. Basically reef would fall down, and exactly like I showed you in the mini ocean, the bigger the boulder you are, the fastest you're going to settle, and the smaller the boulder you are, the furthest you're going to go. Well, believe it or not, this avalanche there got preserved in the coastline of Gross Morn. So the boulders here are around that size. You go down to Cow Head, beautiful community of Cow Head. There's a little isthmus and a little peninsula that local people call the Head, or Summerside, where the summer homes used to be, for close to the fishing grounds. There's a beautiful community trail there. It's not a parish trail, but we walk in Tuckamore Forest. There's little cliffs. You have stunning views over the Long Range Mountain, and you end up on a beach where you see a limestone conglomerate, and blocks are that size. Some blocks in some areas are as big as cars. That's this part of the avalanche. While you go down to Lobster Cove Head, there's a couple places where you see little conglomerate that is loony and toony size. It got preserved in the coastline right there. Okay, we've known a few